Hello and welcome back to the course on blockchain. And today we have an extra tutorial that I originally wanted to include in the mining difficulty tutorial, but then it became just too long and I didn't see it quite necessary. So this is like a kind of a bonus topic, if you will, about how you can derive the current target, how it's actually stored in the blocks. So you don't have to take this tutorial. There will be some calculations, not complex math, but some tedious calculations. And you might find it interesting. On the other hand, you might find it not useful. So feel free to skip this tutorial. But nevertheless, I've personally found this concept interesting, and that's why I decided to record this. All right, so let's have a look. We talked about this in the difficulty tutorial, how difficulty is related to target. Difficulty is the current target divided by the max target. And so here we can see, we can see that the current target has that many leading zeros and it has that number over there. And then the max target has that number there and that many leading zeros. And so interestingly enough, we're going to find out as well today why there's so many leading zeros, why it's not like a proper number, why there's only like 6 digits here, or 4 digits here. It's actually 6 with the zeros. But yeah, so why it's not a proper number, why is it like a truncated type of number? So it'll be kind of like an extra piece of knowledge that we'll get from this tutorial. It's going to be like a side conclusion. It's not the main thing that we're after. The main thing we're after is where is this target stored? All right, where is it stored? Remember last time how we did it? We just went through the blockchain and examples of the blocks to find the current target. We just looked at the number of zeros in the blocks and we decided, okay, so it's 18 zeros. But how do you get the exact value of the target? So that's what we're after today. So where is the current target stored? Well, if we look at an example of a block, you will see here it has a field called bits. That's part of the information that's stored in the block. And you see there's no field called target. There's no actual hash target here, but they do have this field called bits, and that's not it's not the size or anything. It's not like megabits or kilobits. It's a code. It's a code that's stored here. And today we're going to learn how to read that code and how to, from this code, get this number. It sounds like they look completely different, yeah, but at the same time that's exactly where it's stored. So let's have a look how we're going to do this. All right, the first step is to take this value, bits, and turn it into a hexadecimal number. So I'm just gonna have to remember what it is here. So it's 392.009.692. All right, so we're gonna go to a hex calculator and we're gonna go 392.00692. Was that right? 392.009.692. 009.692. Convert. There's a hex number. Okay, copy it. And well, we don't really need to because this is a slide. So there's our bits and there's our hex number. So you can see it's exactly the same number as I got here. So this is basically our bits is a number in decimals. In the decimal system, this is in hex. All right, so you can see we're already getting close. So you see the suspiciously similar thing here. 5997 DC, 5D97DC, 5D97DC. So we can already see that that's a component. What about this first thing? What do we do with that? And that's all we have to find out here. I saw this YouTube video on somebody explaining how to do this, and it was so complex I got scared at the start, but it's actually not that hard. So here we've got 17. What we need to do is that's in hexadecimal. Now we need to convert those first 2 digits back to the decimal system. Because it's funny because we just got this number from the decimal system. We convert to the hexadecimal. Now we need to convert this back into the decimal system. All right, so how do you do that? Well, the 7 stays as a 7, right? Or, well, basically it's, if it was like an A or a B or a C or so on, you just need to convert to what that means. Like in, like a like A would be like a 10, a B would be 11, and so on. And then here you gotta multiply whatever you see here by 16, right? So again, that's just the way this system works. It's a hexadecimal system, so that's the conversion rate, if you will, into back into the normal system. That's what we get, 16 times the number here plus just the number here itself, but don't forget to convert them into decimals if they're like letters. And so we get 23. So 17, or you could just use another calculator. 17 in the hexadecimal system is equal to 23 in the decimal system. And that makes sense, right? If you think about it, like 10 in the hexadecimal is actually 16 in the decimal, because that means this digit was like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then it went over to a 1 here, which means it got to 16. And then 0, 1, 2, 3, 4, 5, 6, 7. And so that means 16, that represents 16 plus the 7, 23. And so then what that means is this number, this is a code. This is basically not just a number, this is a code. The first two digits represent the length of the resulting number that we want in what is it, in bytes. So that means our final number here that we're after is actually 20, or that means like, yeah, that means our final number that we're going to be building is 23 bytes long, right? So what we're going to do now is we're going to draw 23 times 2, important to multiply by 2, so 46 hex digits. Why are we drawing 46? So that's the length of our number. So 23 bytes is actually 46 hex digits. Why is that? Is because if we look at like in a hexadecimal digit takes up 4 bits always, because you know it's 2 to the power of 4 is 16. So here you have two options, times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So a hexadecimal number takes up 4 bits. And then if you take 23 bytes, that's actually 23 times by 8 bits, because a byte is 8 bits. And that means 23 times 2 times 4 bits. And that is 23 times 2 times a hex digit. So 4 bits is a hex digit. So that means 23 times 2, 46 hex digits. I know this is crazy amount of like annoying bits and bytes calculations, but that's what it is. That's the justification while we're multiplying by 2. So you take this, you convert it from hex to decimal, multiply it by 2. That's how long your number is going to be. And then this is the most significant component of the number, meaning that this part needs to be put in there. Bam, put it in there. That's it. And so that's the number. You can see that's exactly our number. And what else we do? We're just going to add these leading zeros to make it look like a 64 digit hex number, to make it look like a proper 64 SHA-256 hash. Boom. Add missing zeros, which they are 64 minus 46 of. Why 46? Because we know that this is 46 long. So 64 minus 46, 18. Put the leading zeros in. Voila. There we go. That's our current target. So again, not compulsory, this knowledge or tutorial, but if ever you need to derive the target, or if you want to do like some development work with blockchains and develop applications and so on, and you'll need to like dig in and find out how the target is stored, or like with Bitcoin, you'll need to somehow get that number. This will hopefully save you some time, because the explanations I found online, there was just only like a few that got to the point quickly. And yeah, so hopefully this makes sense, and don't get worried if this is like too much to handle, these bits and bytes and so on. Just remember that the target is actually stored inside every single block, but it's stored as this value, this field called bits, and it's actually stored like that because it's a code. It saves space. So instead of storing this whole number like that, where, you know, every digit is actually 4 bits. So as you can imagine, that's quite a big number to store. Whereas in you can just store it as a code. You can encode the length of the number with the first 2 digits, and then you can encode just the most significant digits like that. So the length of the number is encoded in bytes, and for everything else is derived from there. Okay, so there we go. I hope you enjoyed today's tutorial. I look forward to seeing you back here on the next one, and until then, enjoy blockchains.